Hi everybody, my name is Sherry Sassmannshausen and on behalf of my co-authors Jörg Radke, Nino Bohn, Hassan Hussein, Dave Rendell and Volkmar Pipek, all from the University of Siegen, I'm going to present our paper Citizen-Centered Design in Urban Planning, how augmented reality can be used in citizen participation processes. While current research already involves concepts for e-participation, there are still few practical approaches for visualizations and 3D experiences for citizen participation. But some studies suggest that visualizations help participants to see better and feel more informed about building projects than traditional methods. More concretely, AR offers citizens the chance to participate in urban design. Research also has shown that the youth is seldom involved in planning processes. Hence, their needs are excluded. Augmented reality can engage them to participate and inform about building projects. Also, there are few human-centered approaches for AR design. Considerations of spatial awareness and 3D are still rare. But several prototyping methods exist and can be adapted for AR. Low-fidelity prototyping methods offer several benefits, which I will show afterwards. As our contribution, we address the options that might increase the interest and creativity of citizen participation. We explore the potential of augmented reality in urban planning and how that might motivate especially young people, paying attention to the benefits that may accrue from spatial and contextual cues. In sharing our experiences with the design process, we show how a participatory design approach engages citizens to design and prototype AR systems on their own. Our design approach is oriented on the human-centered design process. To analyze the context of use, we conducted empirical studies, which contains document analysis, interviews, surveys, as well as focus groups. That helped us to gain a deep understanding of different user needs, which were translated into requirements. Based on that, we conducted 4 participatory design workshops, which resulted in low and high fidelity AR prototypes. In considering different use cases, the design solutions were continually evaluated and refined iteratively together with real users. In our empirical studies, we conducted interviews with 26 citizens, 9 politicians, and 5 government employees. We had a survey with 83 citizens and focus groups in terms of group discussions and observations with 25 participants, mainly young citizens. We recognize that previous citizen participation formats were not sufficient to address a broad range of the population and motivate them to participate, but it's so important to integrate citizens in urban planning to know about their needs. Still too few young citizens are currently involved in participation processes. It is desired to involve more of them because they are primarily affected by the consequences of today's decisions, as the city is built for them. It turns out that young people have many wishes for a redesign, but they think that they are not heard. Young people do not feel they are taken seriously and are not very involved, but they would like to participate more. While citizens have some ideas for the redesign of their city, these should be made comprehensible with visualizations. This leads to augmented reality. The participants mentioned the potential of AR to perhaps already look at things that one finds interesting, or where also get information presented, for instance, buildings. Social media integrations are also mentioned. Facebook and Instagram are currently used as essential platforms as they reach many people. With participatory design, users were involved during the design process. The findings and requirements from the empirical studies served as input for the workshops. There, citizens were able to create own individual design concepts. We also intended to address the challenges of designing for AR and identify possible prototyping methods for systems with spatial references. In 4 workshops, 20 citizens participated and designed AR prototypes. We used design thinking, which is known to be an efficient way to prototype as early as possible. For traditional 2D screen-based products, it's easy to implement, but for AR, it's more difficult due to the spatial dimension. The lack of efficient, low-fidelity methods is a limiting challenge in prototyping AR applications. That's why we explored possible approaches for low-fidelity prototyping in the AR context. In the conception phase, the first step was to individually create ideas for the redesign of the city area, which was then further developed in the team. They used several materials like Lego, clay, or craft materials. On the left you can see they also used transparent sheets to overlay a lakeshore poster and sketch mock-ups for augmented reality user interfaces. It showed the importance of the real environment in the design process. When using flat sketches, some participants described it was easier to sketch in 2D, but it was difficult to explain. Therefore, a 3D view might be appropriate. Lego and the use of other haptic 3D tools were preferred for prototyping because it supports some degree of tangibility or spatial reference. It seems to be promising for AR development because it provides spatial awareness, flexibility, and a familiar common basis. In this way, even low-tech citizens are able to prototype an AR app. The results on the left show also that citizens would like to place 3D objects in the city using an AR app and share the idea in social media. For more collaboration, the participants suggested the use of a 3D AR table, which you can see on the right. On that table, the citizens can place new objects and move them to show and discuss with others. Finally, we implemented a handheld augmented reality app for different use cases in urban planning by using Unity 3D and the frameworks Vuforia and AR Foundation. With two specific use cases, we addressed two types of citizen participation. Firstly, gathering input and ideas with co-design opportunities from citizens, and secondly, informing citizens with options for discussions on planned projects. Use case 1. The redesign of a lakeshore area. In our partner city, the current environment of a lakeshore will be redesigned. Ideas from citizens are required. For instance, some of them wish to have more possibilities to sit near the water. With our AR application, individual designs of the lakeshore can be created, in which digital objects are placed in the real environment. So predefined 3D objects are provided and can be placed, scaled, or deleted from the users. They currently have a selection out of 2 benches, 2 trees, and 2 trash cans. Besides, as social media is already used for citizen participation, we also integrated Facebook, so that a screenshot of the redesigned area will be published into an existing Facebook group. The second use case is about visualizations of different building designs. The existing city town hall of our partner city needs to be redesigned. With our AR prototype, we show different designs so that the citizens can imagine what a possible new building might look like in the real environment. For the prototype, 2 alternative building designs were created. Every design will be overlaid as a digital object over the existing building in the real environment. It is possible to add comments at any point on the digital object, which you can see here as a red dot. As a conclusion, I can say we have shown the potential of AR for citizen participation in urban planning and think it can make a significant contribution to a new form of participation, which may motivate especially young citizens, as they are most affected by the impact of urban planning. We address different levels of participation, such as informing, co-determination with discussions, co-design with citizens' individual ideas. We also share our experiences in the design process of the AR participation app. Our approach shows that Lego prototyping and the use of haptic materials like clay are promising tools for AR development. That approach allowed even low-tech users like citizens to create and prototype ideas for high-tech applications like an AR app. Overall, we found that users reacted positively to the use of AR for planning purposes and to the participatory methods we adopted. But this does not mean that we have solved all problems associated with either the use of technology for urban planning or indeed AR. But we proposed a solution in which citizens are motivated to participate, but there are still issues regarding tokenism and co-optation. For real-world outcomes, the entire participation process must be considered. For democracy, it is also up to the city administration to actually consider the ideas of the citizens. Our work is intended to be an assessment of potential in relation to both, motivating participation and potentially making it easier and urban planning more comprehensible. Our work can be seen as an initial step towards reducing those inequalities by furnishing young people with some of the skills they need to participate more fully. Also, a summative evaluation and study of appropriation is still needed, which will be conducted after the corona situation. We will observe and evaluate the social and collaborative interactions by using the tool. And also design and technical limitations need to be considered in future developments, like for instance, environmental conditions or occlusion problems. Thank you all for watching. For more details, I would also encourage you to read our paper.